Hello geometry students, and welcome to a video on translations in synthetic geometry, meaning again that we are now going to venture away from the coordinate plane, and our goal here is to identify and draw translations without that plane. So no x, y's, no ordered pairs at all here. Okay, we're just getting to the real meaning of translations. Okay, so you're going to need a couple of tools for this. You're going to need something to measure distances, just like we've used before. And I know this is usually what you think of to measure distances, but you need something to make parallel lines, and ideally a transparent ruler. I'll show you how to do it without a transparent ruler, but it's just not quite as good. So if you do have anything like that, that would be helpful. Okay, so first of all, we need to review a couple, or introduce some vocabulary and review some vocabulary. So the first thing is the word parallel. Now, a lot of times people think of the word parallel and think, oh, that's two lines that never meet. And I would say, well, you're partly right, but not completely right. And the reason is, if you look at these two lines, they don't look parallel to me, and yet they'll never meet. So that definition is just not quite good enough to really describe what parallel means. If that picture doesn't work for you, how about a box? You can pretty much take any box, and I don't know how this is going to work in the video. But I have a box of baking soda, and if you just imagine this line right here, and of course the one on the other side, that's parallel. These two lines are parallel to each other. But imagine this line right here, and let's say this one down here that goes this way. Okay, this line that goes this way and this line going this way, you can take any box and hold it and sort of get a feel for this. They will never cross, and they are definitely not going in the same direction. So we need to say something else here, and that is coplanar. Now it will work. The definition will work. So now if we take any coplanar lines that don't intersect, then they will be going in the same direction, and that does capture the meaning of the word parallel. Okay, now a new word, vector. You've probably heard of this word, but never quite had a definition for it, and we're going to use it in doing translations. So a vector is a segment. It's not exactly a segment. We have to start somewhere, though. So it's a segment that has both a direction and a length. So I'm going to start off by writing it, and then I'll explain it better. Okay, so a segment with both direction and length. Now, we think of it as length. Sometimes that word length is magnitude. It's just called magnitude in applications, or if you were to look up vector online, you'd probably see it's a segment with both magnitude and direction, something like that. Okay, so magnitude is the word that you hear, but for our purposes, we can think of it as a length. Okay, so a translation is an image is a translation if all points in it are in the same length, the same distance. Same distance, just because of the way this is worded. The same distance from their corresponding pre-image points and in the same direction. With this, now because the distance and the direction is exactly what a vector is, that means that all vectors which connect a pre-image point with its corresponding image point will be the same. Okay, all vectors that connect them will be the same. Let me just kind of go to the bottom of the page and show you that's a vector right there. Now, a vector can be anywhere as long as it's that long and pointing in that direction. So if you want to talk about two equal vectors, or two vectors that are the same as each other, as long as they have that length and they're parallel to this, they're going in the same direction, those would be considered to be equal or identical vectors. Okay, so that's what that's saying here. Right? Once we've established that the meaning of a translation is going in the same direction and the same distance, we'd say, well, that means that the vectors would be all the same, going from pre-image to points to image points. Okay, so common notation for vectors. Okay, now we've already seen a notation for translations in the coordinate plane. We've seen something like this, right? This is a notation, and this is called transformation notation. And we can easily write this in a shorthand, which is vector notation in the coordinate plane. And the way we do that is very simply, if we want to say x, y, goes to, I'm just going to use the same one that we're just looking at, x plus 5, comma, y plus 7. Then instead of using, this is transformation notation, instead of using that, we can use what's called vector notation, which is much shorter than this, and just 5, 7 looks like this. It's pointy, like it's not really parentheses, they're pointy, and you have to put the 5 and the 7 in there, just like that. Whenever you see these pointy parentheses, or whatever you want to call them, they're pointy though, whenever you see those, you're talking, and this is universal, as you move forward in math or physics, or anything that uses vectors, you're going to see this notation a lot. Okay, so that's vector notation in the coordinate plane. We've also got a vector notation outside of the coordinate plane, and it looks kind of like this, right here. There's what the vector looks like outside of the coordinate plane. Now let's look really closely here. It's got a little arrow over it. So it's not just like a segment notation, it's a little arrow notation over a lowercase letter. Now, not to be confused with array. This is not array. So let me just remind you real quick here, some of our old notes from the very first week of school, when we talked about array, a line that extends in one direction, and we have this notation for array. Now, you cannot have a single letter there. When you're notating array, you have an endpoint, and you have some other point that's in the direction that the array is pointing. Always 2 letters. Okay, that's array. But with a vector, it's not 2 letters. It's just 1 letter. So when we're looking at a vector, we have a notation like this. And so a common notation for vectors would just be something like this, which just means, and you could put a double arrow over it too, it just means the direction of the vector and with the same length. Okay, there it is. So vector v means the direction of the vector and with the same length. Now, I just added something up here to just sort of put the general case. I gave you a specific example with numbers, but in general, vector AB means it's the vector that goes from, this is transformation notation here, that means xy goes to x plus a, y plus b. If they're negative numbers, then it would be plus a negative number, so it would be essentially a negative number. All right, ready for the fun part? Let's draw a vector. So we're going to use our tools now to draw a vector and to actually translate this image according to this vector. In other words, I want to move this image. Let me zoom in a little bit here. I want to move this image this far and in this direction. Okay? So here's what we're going to do. We're going to sort of use our rulers to eyeball parallel lines. And for this one, you actually don't even really need a clear ruler. It doesn't help you as much for these as it helps you for the, I'm looking for my wooden ruler, but I don't see it. It doesn't help you as much for these as it helps you for the reflections. So here's how you do it. You take the ruler and you just line it up until it looks like it's parallel. Now if I want to go through each point, so I'm going to go from each of the 4 points. And if I have it like this, it looks pretty close, but it looks like it's kind of, that. It doesn't look like it's going in the same direction. So I kind of want to rotate it until it looks really good. And then I want to draw a line that's longer than necessary, like this. Nice and long. Okay? And I'm going to do that for all 3 of the points. So I'm going to do that here. And the more you have, and notice I'm not holding my ruler this way, because then I block the lines. I can't tell parallel. I have to hold the ruler so I can see the parallel lines, but I'm trying to make it parallel too. Okay, there we go. That looks like it's good right there. So let's draw the line. And let's do it one more time from this point, and we're going to draw the line. Now these are actually a little bit, let's try to get it just right. There we go. These are actually a little bit easier to do than reflections, because when you use your measuring paper, you only have to measure the length of the vector once and then duplicate it for every point that you have. So I'm just going to measure it 1. Notice I've got my marks from before. Well, if you want to see a little clean, we'll make it clean. So from there to there, and I go right to the tip. Always go to the tip of the arrow, and that's the length of the vector. So now I'm going to duplicate it on this line. So I put the corner right there, and I put the mark right there. Okay, then I'm going to duplicate it from this point. So I put the corner right there, I put the mark right there, and then one more time from this point. So I want to get the corner right there, and then the mark right there. All right, those are my points that will, in this, this one's already there. So those are my points that should generate the translation. So let's see what we get. I'm going to connect the points here. And the fun thing about this, and what you really want to look for, is does your final image really look like your original image? Because if it doesn't really look like it, you probably did something wrong. And by the way, these look kind of like three-dimensional prisms. Okay, but here's my image right here. And my image should look like it's the same angles, the same size, the same shape as the pre-image. Should look exactly the same. Of course, nothing is exact, but the best that we can do, and it really, our eyes can't really tell if we did a good job. When we look at it, it's like, wow, that looks like it's exactly the same. And you can tell, you know, there are little things. If you have any tracing paper, here's some tracing paper that I used before. And, you know, you can use this to figure it out. So I'm going to use the top part of the tracing paper here. I'm going to trace the original pre-image like that. And then I'm going to trace the vector. I don't have much of a space here on this particular piece of paper, but it's good enough. Okay, the vector is like that. And then I'm going to just move this, and there it is. It fits. I didn't really need to trace the vector, but there it fits perfectly. So it's just moved along that line. You can actually picture this point moving along the vector. So I keep it right on that line so you can really see the translation. No turning, no rotating, no reflecting, nothing like that. And it should be, there shouldn't be any gaps. So I guess I'm not quite perfect, but pretty close. Okay. One more type of question here, and that's just to look at a couple of pairs of images and just decide whether or not they look like they are either reflections or translations. And if they're reflections, we should draw the line of symmetry, and if they're translations, then we should draw the vector. Okay, so this first one is a reflection. I'm going to pause it and let you try these. Okay, so here's the first two, and since this first one appears to be a reflection, I drew in the line of symmetry, tried to get it right in the middle there. The second one appears to be a translation, so I drew the vector. Now I'm just assuming that this is the pre-image and this is the image. It doesn't really say here, but just because I made this one the pre-image in blue, I thought I'd just be consistent with that. But it really, if it doesn't say, then I have to specify that normally. Okay, so that's the pre-image, that's the image, that's the direction it goes, which means if we follow that same rule here, it's moving from here to here. So you can pick any of the points, by the way. I just picked one that's easy to see. If I go from here to here, from here to here, it would be the same length in the same direction of a vector. It'd just be like kind of overlapping the other line, so it's a little bit annoying. And then here's the last one, it's just neither. Okay? I hope you found this video helpful.